Assalamualaikum and hi everyone. Today we continue with next 3 learning objective. First, we find one-sided limits. Next, determine the existence of the limit of a function. And last, we find infinite limits. Now we start with one-sided limits. The existence of limit x approach a fx depends on the behavior of f on both sides of a. If f approaches the same value as x approaches a from the left and the right side, then we say that limit x approach a fx exists. We use symbol x approach a plus to indicate x approach a from the right side. And we use symbol x approach a minus to indicate x approach a from the left side. We call limit x approach a from left fx equals to m and limit x approach a from right fx equals to l as one-sided limit. Okay, now we look at examples. We have graph here. From the above piecewise graph, find a limit x approach 4 from left. Okay, we look the graph. We look x equals to 4 here. Okay, this area for 4 from right. And this area for 4 from left. Okay, now we want to find limit x approach 4 from left. 4 from left, graf dia adalah yang ini. Ini adalah graf for 4 from left. Sebelah kiri nombor 4. Itu graf dia. And graf ni start at this one. Okay, so dia start at 2. So equals to 2. Okay, now we find B, limit x approach 4 from right. 4 from right menunjukkan graf kamu berada di sebelah kanan 4. Ini adalah graf di sebelah kanan 4. And this graph start at this point. This point is 3. So equals to 3. Okay, C, limit x approach negative 3. Negative 3 is here. Okay, this part for negative 3 from right. And this part negative 3 from left. Okay, now we want to find negative 3 from left. Negative 3 from left, ini graf yang menunjukkan sebelah kiri negative 3. And this graph start at this point, so equals to 1. Okay, 1. We put here answer is 1. D, limit x approach negative 3 from right. Negative 3 from right, graph start from here. Okay, graph, this one graph for negative 3 from right and start at this point. This point is y equals to 4. So equals to 4. Question E, limit x approach 1. So we look at number 1. This one number 1. Okay, on the line, we find x approach 1 from left. 1 from left this side. Ni 1 from left. Sebelah sini adalah 1 from right. 1 from left, kita tengok tak ada pun graf atas nombor 1 ni yang pergi ke arah kiri. Tak ada. So tak adalah. Tak ada answer. Okay, 1 from right, kita nampak dia ada graf di sini. Ni graf from right and start at this point. So equals to 2. Test existence of the limit. A limit exists if and only if both one-sided limits exist are equal. Okay, limit x approach a from left fx. If we get same value as limit x approach a from right, so limit x approach a fx is exists at the same value as a from left and a from right. We look example number 1. Given the piecewise function fx equals to 2x where x less than or equals to 4 and function 2x plus 3 for x greater than 4, find the limit x approach 4 from left, limit x approach 4 from right and limit x approach 4. So first we find limit x approach 4 from left. Okay, we have number line 4. This one 4. Greater than 4 means 4 from right. And less than 4 means 4 from left. Okay, now we want to take function 4 from left. 4 from left means x less than or equals to 4. So we take function 2x. So we put here 2x. Then we solve. We substitute value 4 into x. So we get 2 times 4. So equals to 8. Okay, now we find limit x approach 4 from right. 4 from right means x greater than 4. X greater than 4, the function is 2x plus 3. Then we substitute 4 into x. So we get 2 times 4 plus 3. So equals to 11. So we can see here, limit x approach 4 from left is 8 and limit x approach 4 from right is 11. Not the same value. So we can conclude limit x approach 4 fx does not exist. Why? Since limit x approach 4 from left fx not equals to limit x approach 4 from right. Kita nampak di sini limit dua-duanya tak sama. From left and from right tak dapat value yang sama. So that's why limit x approach 4 tu automatic does not exist. Continue question number 2. Given fx equals to negative 2 for x less than negative 1, 0 for x equals to negative 1, 2x for x greater than negative 1. Find the limit x approach negative 1 from left, limit x approach negative 1 from right, and limit x approach negative 1. For your information, 0, function 0, for x equals to negative 1 tak ada kaitan langsung dengan limit. Limit just approach, not equal. So equal ni kita abaikan lah. Okay. First question ask we to find limit x approach negative 1 from left. Negative 1 from left means we use function where x less than negative 1. So the function is negative 2. Since the function doesn't have x to substitute, so we just copy negative 2. Okay, then we find limit x approach negative 1 from right. Negative 1 from right means we take function where x greater than negative 1. So the function is 2x. Then we substitute value x into function. So we get 2 times negative 1. So equals to negative 2. So we can see here the value for limit x approach negative 1 from left same with limit x approach negative 1 from right. So we can conclude since limit x approach negative 1 from left equals to limit x approach negative 1 from right, so limit x approach negative 1 equals to negative 2. We continue question number 3. Evaluate the following limit. A. Limit x approach 2 from left, x square divided by x plus 2. Okay, we just substitute x equals to 2 into function. Walaupun dia ada 2 from left, so tak perlu buat apa-apa lah, just masukkan sahaja nilai x dalam function. So we get 2 power of 2 over 2 plus 2. So we can answer 4 over 4, so equals to 1. Question B, we have limit x approach negative 2 from left, x plus 3 times with modulus x plus 2 divided by x plus 2. Okay, since this one we have modulus, we know modulus have two functions, negative and positive. So we need to change modulus into piecewise function. X plus 2, we have two sign. First, positive x plus 2, positive where x greater than or equals to negative 2. And negative x plus 2 for x less than negative 2. Why I take x equals to negative 2? We take value inside the modulus. Okay, now we find limit x approach negative 2 from left. Okay, x plus 3. Okay, for modulus x plus 2, we take function less than negative 2. Sebabnya dia nak negative 2 from left. So kita kena ambil function yang x less than negative 2. So we have negative x plus 2 divided by x plus 2. Okay, x plus 2 same with x plus 2, so we cancel out. So we get limit x approach negative 2 from left, negative x plus 3. Then we solve, we substitute x negative 2, so negative 2 plus 3. Then we get answer negative 1. In question C, we have limit x approach 1 from left, square root of 2 times with x minus 1 divided by modulus x minus 1. Okay, since we have 1 from left and we have modulus, so we change modulus into piecewise function. We have two functions. First one is positive x minus 1 and next is negative x minus 1. Positive for x greater than or equals to 1, take value inside the modulus, and negative for x less than 1. Okay, now we want to find limit x approach 1 from left. 1 from left means we must take function for x less than 1. So square root of 2 times with x minus 1 divide by function less than 1 is negative x minus 1. Okay, then we cancel out. Then we get limit x approach 1 from left. This one, don't forget negative. So negative square root of 2. Since this function doesn't have x, to substitute 1. So we just copy negative, set 2. And last for today is infinite limits. Consider the function fx equals to 1 over x. We know that this function is not defined at x equals to 0. Means kalau kita substitute x equals to 0, we get 1 over 0. So this function is undefined. So tak boleh solve lah, but dia undefined. But what is the behavior of the function as x approach 0 from both sides? Tapi kita nak tengok apa yang jadi bila x tu approach 0 from left and from right. We can see from this graph, limit x approach 0 from left. From graph, we know the graph is going down. So the answer is negative infinity. When limit x approach 0 from right, so we can see the graph increase. So this one positive infinity. So bila soalan yang melibatkan number over 0, the answer always positive or negative infinity. Sebab kita nak tengok cara dia menghampiri 0 tu sahaja. Apa yang jadi? Sama ada dia menurun ataupun dia menaik dari segi graf lah. We look example number 1. From the graph fx and gx, we have two graph here. Find a limit x approach 2. Okay. At number 2, we have two graph. First, dua-dua graph ni kita nampak dia menaik ke atas. So 2 from left, this one 2 from left, and this one 2 from right. To find x approach 2, we need to find limit x approach 2 from left. X approach 2 from left, kita nampak daripada kiri graf tu menaik. So positive infinity, dia naik dan dia tak ada stop, so positive infinity. And limit x approach 2 from right fx is so positive infinity, sebab dia pun naik juga ke atas. So limit x approach 2 is positive infinity. Sebabnya left and right dia sama. 1b, limit x approach negative 3 gx. Okay, this one negative 3, and this area for negative 3 from left, and this area negative 3 from right. Okay, to find x approach negative 3, so we need to find limit x approach negative 3 from left gx. Okay, we look at the graph. Negative 3, grafnya menaik ke atas, so positive infinity. And limit x approach negative 3 from right gx, we can see here the graph turun ke bawah. Okay, so negative infinity. Since both are not same value, so limit x approach negative 3 gx is does not exist. We look question number 2. Given hx equals to 1 over x minus 3, question asks to find limit x approach 3 from left and x approach 3 from right. Okay, now we start find limit x approach 3 from left. Hx is 1 over x minus 3. Okay, if I substitute x equals to 3 into function, then I will get 1 over 0. Okay, so sebabkan tak boleh nak solve undefined, so kamu perlu imagine number 3 from left. Okay, bayangkan number line 3, this one 3 from right, and this one 3 from left. Okay, 3 from left means x less than 3. So choose one number yang paling hampir dengan 3, tapi dia kurang daripada 3. So I choose 2.9. 2.9 adalah number yang paling dekat dengan 3, tapi dia kurang daripada 3. So kita imagine 1 over 2.9 minus 3. So we get 1 over negative number. So 1 is positive number and denominator is negative number. So positive, negative, we get negative. Okay, we get negative number. So we put here answer equals to negative infinity. Yang saya buat awan-awan ni untuk kita imagine je. Tak perlu jadikan dia jalan kerja. Dia tak ada jalan kerja. Bagi jawapan dia terus. Okay, we find limit x approach 3 from right, hx same 1 over x minus 3. Okay, if I substitute 3 into function, still get 1 over 0. 1 over 0 is undefined, tak boleh nak solve. So kita choose satu number yang menunjukkan dia dekat dengan 3 tapi lebih daripada 3. So I take 3.1. 3.1 paling dekat dengan 3 tapi dia besar daripada 3. So kita imagine 1 over 3.1 minus 3. So we get 1 is positive and 3.1 minus 3, also we get positive number. So answer is positive, positive, we get positive. So conclusion, the answer is positive infinity. Now we continue number 3. Given kx equals to 1 plus x over x minus 2. Question asked to find limit x approach 2 from left kx. So 1 plus x over x minus 2. Okay, if I substitute 2 into function, so also get over 0. Bila over 0 means undefined. Okay, so tak boleh nak solve. So kita perlu imagine. And this one 2. Ni 2 from left and 2 from right. Okay, 2 from left. One number 2 from left is 1.9. And one number for 2 from right, so 2.1. Okay, so we imagine 1 plus 1.9, 1.9 minus 2. So we get numerator as positive and denominator negative number. So positive, negative is negative number. So conclusion, the answer is negative infinity. We find limit x approach 2 from right, function is 1 plus x over x minus 2. Okay, we take value 2 from right is 2.1. So we imagine 1 plus 2.1 divided by 2.1 minus 2. So we get answer positive for numerator and denominator pun also positive. So positive, positive, positive. So we conclude the answer is positive infinity. We continue last question for today. Number 4, find the following limits. A, limit x approach 4 from right, x over x minus 4. Okay, setiap kali dapat soalan limit, kita test value dulu masukkan. Kita masukkan dulu nilai x tu. Kita masukkan, so we get number over 0. Bila over 0 means undefined. Okay, bila undefined tak boleh, so perlu imagine sahaja. Imagine one number, we take value 4 from right. 4 from right is 4.1. So 4.1 divided by 4.1 minus 4. So we get positive over positive. So equals to positive. Okay, so the answer is positive infinity. Okay, B, limit x approach 2 from left. Okay, we test, substitute x equals to 2 into function. So we get over 0. Denominator pun masih dalam 0. So this one undefined. Bila undefined, kita take one value less than 2. 2 from left means less than 2. Less than 2, I take 1.9. So imagine 1.9 plus 2 over 1.9 square minus 4. So equals to positive and denominator negative number. So equals to positive, negative, negative. So the answer is negative infinity. Okay, and last C, limit x approach 3 from left. Okay, 3 from left, we test, substitute 3 into denominator. So we get 9 minus 9. So we get 0. Okay, so undefined lah, tak boleh nak solve. Then we take one value, we present 3 from left. 3 from left means 2.9. So we substitute 2.9 square plus 2.9 plus 2 over 2.9 square minus 2 times 2.9 minus 3. Positive for numerator and negative for numerator. So positive, negative, negative. Okay, so answer negative infinity. Today we learn about one-sided limit. For one-sided limit, we just substitute x into function and get answer. If we get pattern number over 0, so our answer only infinity or negative infinity. And for the existence of the limit, if answer limit from left equals to answer for limit from the right, so the limit is exists. This question for your exercise. If you have any problem, you can ask your lecturer. Okay, so that's all for today. Thank you.